As the oldest known fabric with history spanning over 30,000 years, linen remains today a symbol of elegance and sustainability in the world of high-end textiles, contributing billions of dollars annually. But how can hundreds of thousands of tons of flax be turned into soft, cool, and high-value fabric? From the golden flax fields of Europe, each stalk is carefully harvested, sun-dried, and delivered to spinning mills. There, under modern machinery and the meticulous hands of workers, the flax goes through a series of precise and delicate processing steps before becoming fine, smooth fibers. These fibers are then woven into premium linen fabric, lightweight, durable, and ready to serve the global fashion industry. Today, join Agriculture Insight as we explore the journey of transforming coarse, dry flax stalks into one of the most sought-after fabrics in sustainable fashion, and uncover the secrets that allow linen to retain its value in the era of mass production. All of that coming up in this video. Of the 700,000 tons of flax fiber produced annually, Europe accounts for 85% of the world's high-quality output. France leads in volume, Belgium is renowned for its refined processing techniques, and the Netherlands stands out with its modern, sustainable cultivation systems. Each year, Europe's linen industry generates around 1.6 billion, playing a pivotal role in the global high-end textile value chain. Compared to cotton, linen has a more rustic texture but is 2 to 3 times more durable, gets softer with each wash, and is almost pill-free. Though more expensive, it offers a naturally cool and highly breathable feel, ideal for summer fashion and premium interior fabrics. Thanks to these outstanding qualities, linen has been embraced by fashion powerhouses like Hermès, Loro Piana, and Ralph Lauren, as a statement of refined minimalism where natural, eco-conscious materials meet elegance and luxury. And every journey has its beginning. For flax, it starts in humble fields, where the plants are harvested through a blend of modern machinery and human hands. Every July, when flax flowers have faded and the stems turn yellow at the base while the tops remain pale green, it marks the perfect time to harvest, ensuring the fibers are long, soft, and durable. Across the flax fields of Belgium, France, and the Netherlands, specialized harvesting machines roll into action, kicking off a process that is both precise and visually striking. Unlike crops like wheat or corn, which can be cut at the stem, flax must be pulled out by the roots to preserve the full fiber length. To do this, the industry uses specially designed flax harvesters, equipped with rotating clamps and root-lifting conveyor systems. As the machines move forward, 2 large rotary clamps continuously grip the rows of flax and pull them upward. The 1-meter-long stems are kept perfectly straight as they move onto conveyors running along the length of the machine. There, the stalks are laid side by side into neat, even rows and gently placed back onto the field. Within minutes, golden-green ribbons of flax are spread across the ground with precision, ready for natural drying. Compared to traditional manual harvesting, modern flax harvesters increase efficiency by 5 to 6 times, while ensuring that the fibers remain straight, consistent, and unbroken. An essential requirement for the high-end linen industry, where every centimeter of fiber is closely monitored. During the process, flax seeds are also separated. The flower heads containing the seeds are suctioned through a system of tubes transferred into a separation chamber and then deposited into bins attached to the machine. These seeds are later used for fertilizer, animal feed, or industrial recycling, while the flax stalks remain in the field to dry. This drying phase allows the natural pectin to break down, making it easier to separate the fibers during the next stage of processing. After 2 to 4 weeks, the flax stalks have reached the ideal level of dryness. At this stage, flax baling machines take over to complete the harvest. These machines are specially designed to handle the light, long, and delicate nature of dried flax stems. At the front, two spiral-shaped pickup arms continuously gather and guide the rows of dried flax toward the center of the machine, feeding them into the central compression system. Inside the chamber, rollers and belts rotate in unison, generating strong pressure to tightly compress the flax into large cylindrical bales, each with a diameter of up to 1.4 meters and an average weight of 250 to 300 kilograms. Once a bale reaches its optimal size, the locking mechanism automatically releases, pushing the bale out the rear of the machine and leaving behind a line of flax wheels, neatly spread across the field. On average, a single machine can produce 25 to 30 flax bales per hour, depending on field conditions and material density. After finishing the job, the machines leave the field while the flax bales are collected using grab loaders and loaded onto specialized trucks for transport. But that's not the only mission of flax. This versatile plant is also cultivated specifically for its seeds, which are harvested to produce a premium edible oil containing up to 7 times more omega-3 than soybean oil. Unlike flax grown for fiber, seed flax must be harvested when the plants are fully mature and have turned brown. At this stage, the seeds have reached peak oil content, their shells have hardened, and the nutrients inside are at optimal levels for oil extraction. Specialized harvesting machines, similar to those used for wheat, are deployed across flax fields to carry out this task. These machines are equipped with onboard grain tanks, allowing for fast, convenient, and efficient seed collection and transport. As the machines move along the flax rows, sharp blades cut the stalks close to the ground, or sometimes uproot the entire plant. The harvested material is fed into a threshing chamber, where a system of crushing and screening separates the seeds from the stems. The seeds are then conveyed via an internal belt system into a large onboard storage tank, while the remaining stems and husks are expelled out the back, forming an organic mulch that helps enrich the soil. These modern harvesters feature high-capacity tanks that reduce the need for frequent unloading, optimizing efficiency for large-scale operations. Their smart design ensures high yields while preserving the quality of the seeds for the next stage of processing. And when the harvest is complete, both the stalks and the seeds make their way to processing facilities, where they continue the story of this extraordinary plant, from fine linen fabric to a rich source of essential nutrients. Now, let's dive into the process of making the oil hailed as the omega-3 king of the food world, flaxseed oil. As soon as the flax seeds arrive at the processing facility, they are sent through a cleaning line. Here, the seeds are screened, dehulled, and separated from dust, debris, and empty shells. Next, they are passed through a grinding system to break the outer husk, making the oil extraction process smoother and more efficient. Flaxseed oil must be extracted using a cold press method, with the temperature strictly maintained below 40 degrees Celsius (140 degrees Fahrenheit) to preserve the full omega-3 content. This is the key factor that gives flaxseed oil its superior nutritional value compared to other vegetable oils. After pressing, the crude oil is further filtered to remove fine particles and impurities before being bottled in dark glass containers to reduce oxidation. This is crucial because flaxseed oil is highly sensitive to light and air. Improper storage can cause it to lose nutrients and develop off flavors. The final product is a pale golden oil with a light nutty aroma and a mild, smooth taste, hailed as one of the healthiest edible oils for heart and brain health. Now we return to the most anticipated part, the journey of transforming coarse, dry flax stalks into premium linen fabric, the very material that has defined the prestige of the global sustainable textile industry. Upon arrival at the factory, the dry flax bales are delivered to the receiving area. Here, workers conduct an initial assessment of moisture content, fiber length, and remove any bales that fail to meet quality standards before proceeding to the next stage. Once the inspection is complete, the bales are sent into the preliminary separation system, where they are unwrapped and loosened. A conveyor belt feeds the flax bundles into the spreading machine, where spiral gears and high-speed rollers work together to continuously tease apart, untangle, and evenly distribute the dry stalks into flat layers. This mechanism breaks up the naturally compact structure of the bundled flax, creating ideal conditions for the fiber separation stages that follow. At the same time, larger impurities such as roots and woody fragments are filtered out right from the start. Once the flax bales have been spread out, they move on to the fiber opening machine, which breaks up the tightly bound structure, allowing the flax fibers to loosen and separate more freely. Inside the machine, fiber clumps are fluffed up by high-speed rotating shafts and powerful airflows, transforming them into a light cloud-like layer. This airy fiber layer then falls onto a vibrating conveyor belt, which simultaneously transports and evenly sifts the fibers downward, filtering out fine dust and enhancing the loft and uniformity of the material. At the end of the conveyor, a set of shaping rollers, typically 2 to 3 slow-turning cylinders with grooves or soft bristles, gently compresses and aligns the flax fibers in a single direction. This process creates a smooth, parallel fiber sheet with consistent thickness and spreads it evenly across the delivery slats, making it easy to roll into compact, sturdy fiber rolls. After being rolled up, the raw flax fibers are stored and later transported to weaving mills, the next stop on their journey to becoming finished linen fabric. Upon arrival at the weaving mill, the raw flax fiber rolls are sent to the combing area, where the fiber bundles are further disentangled and refined. Here, the combing machine features multiple rotating rollers embedded with fine metal pins or brushes. As the fibers pass through, these pins stretch, straighten, and remove short or excess fibers, leaving behind only the long, smooth, and uniform strands, essential for producing high-quality yarn. The result is a series of smooth, parallel fiber bundles known as slivers. The slivers are then fed into a parallel drawing machine, where they are combined and stretched repeatedly to ensure consistent length and density. During this process, the fibers pass through successive sets of rollers, with each pair rotating faster than the previous one. This controlled stretching makes the slivers finer without breaking them. After 2 to 3 rounds of drawing, the fibers reach the desired fineness and uniformity needed for the actual spinning phase. This next step is crucial for transforming the delicate slivers into true flax yarn. Inside the spinning machine, each sliver is passed through a system of rollers and spindles that simultaneously stretch and twist the fibers. The level of twist is carefully adjusted depending on the desired yarn type. Tighter twists for fine, high-end fabrics, and looser twists for thicker, splied but more robust textiles. Finally, the finished yarn is wound onto bobbins or spools, ready for weaving. Depending on the product design, the flax yarn may be dyed before weaving. In the dyeing room, yarn spools are placed into rotary dyeing vats, where dye solutions are circulated and thoroughly absorbed into each fiber. This process requires precise control of temperature, pH, and timing to ensure even, long-lasting color that won't fade after washing. Once the flax yarn is fully prepared, it moves on to the weaving machines, where the actual construction of fabric begins. Warp threads are aligned parallel and stretched tightly across the loom, while weft threads are inserted back and forth using a shuttle, needle, or airjet system, depending on the type of loom. With each weave, the loom lifts and lowers the warp threads in a programmed sequence to form patterns, while the reed beats the weft into place, producing a strong, cohesive fabric. Modern weaving speeds can reach 500 to 800 picks per minute, generating dozens of meters of fabric every hour. After weaving, the linen fabric is inspected for defects, then rolled and sent to finishing stages such as washing, softening, drying, cutting, pressing, and packaging, ready for the market. Cotton plants are like the superstars of the agricultural world. They grow their own outfits. These shrubs produce fluffy white balls of fiber that not only look soft and cuddly, but also make everything from your favorite jeans to that shirt you've been wearing since college. Native to warm regions, cotton thrives in sunny fields, soaking up the heat like it's on a permanent vacation. With roots that dig deep into the soil and leaves that fan out like tiny umbrellas, the cotton plant is as hardworking as it is stylish. Farmers plant cotton seeds in spring, spacing them out like disciplined little soldiers. Over the next 6 months, the plants grow into knee-high bushes, their leaves soaking in sunlight like mini solar panels. With regular irrigation, fertilization, and pest control, the plants mature and begin to produce their prized fluffy bolls. When the fields start to look like they've been dusted with snow, it's harvest time. In its early days, the cotton industry was a game changer, albeit one built on hard labor and rudimentary tools. Long before mechanical harvesters roared across fields, cotton was painstakingly picked by hand, often by enslaved workers in the southern United States. The invention of the cotton gin by Eli Whitney in 1793 marked a pivotal moment, turning cotton into a profitable crop almost overnight. Globally, the demand for cotton skyrocketed during the Industrial Revolution, with textile mills in Britain and beyond spinning the fibers into fabric, cementing cotton's role as the lifeblood of the early modern economy. From humble, labor-intensive beginnings, the cotton industry laid the foundation for industrialization and global trade, proving that even the fluffiest of plants can shape history. Harvesting cotton in the United States isn't just a farming activity. It's a spectacle of modern technology, skill, and logistical coordination. With millions of acres of cotton fields spread across states like Texas, Georgia, and Mississippi, farmers rely on both manual labor and cutting-edge machinery to get the job done. Before mechanical harvesters became the norm, cotton was harvested entirely by hand, a painstaking process that required workers to pluck each boll individually. Even today, some small-scale or specialty cotton farms use manual harvesting methods. Why? Because hand-picking ensures minimal damage to the fibers, producing higher-quality cotton. Imagine walking through acres of fields under the hot sun, filling sack after sack with fluffy bolls. It's back-breaking work, but the precision is unmatched. Hand-picked cotton is cleaner, with fewer leaves and stems mixed in, which means less cleaning during processing. While it's not common in the US anymore, manual harvesting remains a critical method in many parts of the world. For large-scale cotton farms, mechanical harvesters are the heroes of the day. These machines are like the transformers of agriculture, powerful, efficient, and a little intimidating. In the US, farmers primarily use 2 types of harvesters: cotton pickers and cotton strippers. Cotton pickers. These machines are designed to be gentle yet efficient, like a farmer's version of a robotic masseuse. They use rotating spindles to carefully pluck the cotton fibers from the plant without disturbing the rest of the bush. Cotton pickers are ideal for fields where plants are uniformly spaced and bolls are ripe. The result? cleaner cotton, and less debris to deal with later. Cotton strippers. For fields with uneven plant heights or late-season harvesting, cotton strippers take over. These machines are less selective, pulling in not just the cotton bolls, but also leaves, stems, and other plant material. The cotton is cleaned later during processing, but this method is faster and more efficient for fields that need a quick sweep before the season ends. The adoption of modern machinery in cotton harvesting has revolutionized the industry, offering efficiency, cost savings, and improved quality. Machines like cotton pickers and strippers significantly reduce the time and labor required to harvest large fields, allowing farmers to manage thousands of acres quickly and effectively. This speed is especially crucial during peak harvest seasons, when delays could lead to crop damage from weather changes. Additionally, high-tech harvesters are designed to minimize cotton waste and ensure cleaner bolls, reducing the need for extensive processing later. Advanced features, such as GPS and precision farming technology, enable farmers to optimize harvesting patterns, saving fuel and lowering overall costs. Beyond efficiency, the use of machinery also addresses labor shortages, a common challenge in agriculture. Moreover, modern equipment reduces physical strain on workers, making cotton farming more sustainable and scalable for the future. Once the cotton is harvested, it's compressed into giant bales weighing about 500 pounds each. These bales are wrapped in weather-resistant coverings and tagged with unique identifiers. This step is crucial for tracking the cotton's journey from the farm to the gin. Imagine a giant marshmallow being tagged and shipped. That's basically what these bales look like. The bales are then transported to nearby cotton gins, where the next phase of the cotton's transformation begins. The cotton gin is where the real magic happens. This ingenious machine, invented by Eli Whitney in 1793, revolutionized the cotton industry by automating the tedious process of separating fibers from seeds. Modern cotton gins are technological marvels, capable of processing thousands of pounds of cotton per hour. When the cotton bales arrive at the gin, they're unwrapped and fed into the gin's machinery. The cotton is fluffed and loosened to prepare it for the separation process. This step removes large clumps and ensures that the fibers are evenly spread for efficient processing. The ginning process involves separating the cotton fibers, known as lint, from the seeds and other debris. High-speed rollers or saw blades gently tease the fibers away, leaving the seeds intact. These seeds are collected for further use, often being pressed into cottonseed oil or sold as feed for livestock. The lint, now free of seeds, is cleaned further to remove any remaining dirt, stems, or leaves. This cleaning ensures that the cotton is as pure and soft as possible before moving on to the next stage. Once cleaned, the cotton lint is compressed into dense bales weighing about 480 pounds each. These bales are wrapped, labeled, and shipped to textile mills, where they'll be spun into thread and woven into fabric. Each bale is tracked to ensure quality control and traceability, making sure the cotton's journey is as smooth as its fibers. Textile mill, the cotton fibers are carded, which means they're brushed into long, thin strands. These strands are then spun into thread using high-speed spinning machines. The thread can be dyed, woven, or knitted into fabrics for clothing, home goods, and even industrial uses. The transformation from fluffy field fibers to finished fabric is nothing short of extraordinary. Starting as fluffy bolls in the field, cotton is harvested, cleaned, and spun into threads that weave the fabric of everyday life. These threads are dyed, shaped, and stitched into everything from soft t-shirts to durable jeans, cozy sheets, and even medical supplies. Along the way, cotton fibers undergo transformations that highlight their versatility and strength. By the time it reaches store shelves, cotton has traveled from farm to factory, carrying with it the effort of countless hands and the innovation of modern technology. Cotton is more than just a crop. It's a cornerstone of the U.S. agricultural economy. It contributes billions of dollars annually and supports hundreds of thousands of jobs, from farmers and ginners to textile workers and exporters. The U.S. is one of the world's largest exporters of cotton, supplying high-quality fibers to countries across the globe. Cotton has been woven into the fabric of American life, literally and figuratively. It's the material behind iconic blue jeans, soft t-shirts, and cozy bed sheets. Historically, it played a pivotal role in shaping the U.S. economy and society, particularly during the Industrial Revolution. Today, it continues to symbolize comfort, resilience, and sustainability. From the sun-drenched fields of the American South to the high-tech gins and textile mills, the journey of 3.6 million tons of cotton is a testament to human ingenuity, dedication, and the enduring appeal of this fluffy crop. Whether it's a soft t-shirt, a sturdy pair of jeans, or even a dollar bill, cotton touches every corner of our lives. So the next time you wrap yourself in a cozy cotton blanket or slip into your favorite shirt, take a moment to appreciate the journey of those fibers. Behind every thread is a story of hard work, innovation, and a little bit of fluff. Before modern cigarettes came into existence, humans had been using tobacco leaves for thousands of years. In ancient Mayan culture, tobacco was considered a sacred gift to the gods. By the 16th century, it had followed European explorers to the New World, then spread across the globe, becoming intertwined with colonialism, war, and the glamour of Hollywood. You may have never seen a tobacco plant with your own eyes, but every year, the world still harvests over 6 million tons of tobacco leaves, fueling an industry worth nearly $900 billion. China currently leads in production with more than 2.6 million tons annually, but the most famous tobacco brand in the world comes from the United States, Marlboro, which accounts for up to 14% of global consumption. And you, what's your number one brand? And every great story has a beginning. For this smoky muse, it all starts in the sun-drenched tobacco fields, where warm summer breezes signal the first whispers of harvest. From around July to September each year, the tobacco fields enter harvest season. Harvesting requires great precision, relying on both experience and traditional principles. Specialized machines move slowly through the head-high rows of plants. Beneath them, a system of sharp rotating blades precisely cuts the mature leaves close to the ground. Immediately afterward, soft conveyors receive and lift the leaves, preserving their shape and moisture while minimizing tearing or bruising. Leaves must be picked when they are not too wet to prevent bruising, yet not too dry, which makes them brittle. The ideal temperature is between 20 to 25 degrees Celsius, and harvesting typically takes place between 5 and 9 a.m., when the leaves are still supple and retain a healthy sheen. The leaves are delivered directly into a large ventilated container at the rear, designed to prevent moisture buildup and premature fermentation. Once full, an automatic unloading system transfers the leaves to a detachable bin or a specialized truck moving alongside. On average, a single machine can harvest about 5 tons of fresh leaves per day, 8 to 10 times more efficient than manual labor, while also reducing risks and improving efficiency across the entire production chain. At some cigar tobacco farms, machines are used to harvest the entire plant. These devices cut the stalk at the base, Gently lift the full row and automatically hang the plants onto integrated curing racks, ready for drying. Notably, keeping the stalk intact allows sap to continue distributing into the leaves during drying, making them softer, more elastic, and rich in natural oils, crucial qualities for producing smooth, flexible, and glossy wrappers for premium cigars. In Cuba, Nicaragua, and the Dominican Republic, the birthplaces of hand-rolled cigars, the tradition of harvesting by hand is still carefully preserved, serving as a tribute to the leaves that will become the soul of premium cigars. Unlike the mechanical precision of machines, manual harvesting follows a slow, deliberate rhythm rich with craftsmanship. Skilled workers closely examine each leaf, using its color, sheen, and elasticity to judge the perfect stage of ripeness. After harvesting, the leaves are bundled into small groups and placed in woven baskets or breathable racks to maintain their shape. Though labor-intensive and slower, this meticulous process is what gives handmade cigars their unique value. Why a single premium cigar can fetch hundreds of dollars, while a pack of machine-made cigarettes costs just a few. From here, the leaves begin to diverge, some destined to become artisanal cigars, others entering the industrial pipeline of mass-market tobacco. Let's begin with the remarkable story behind every cigar. Not just something to smoke, but a product born from time, technique, and traditional craftsmanship. Immediately after being harvested, tobacco leaves enter the curing stage, the first and one of the most critical steps in cigar production. The leaves are hung in curing barns or sheds, where temperature, humidity, and airflow are tightly controlled. Depending on the leaf variety and desired flavor profile, different methods may be used. Sun curing, air curing, smoke curing, or heat curing. This process usually takes several weeks and requires great precision, as even small deviations can significantly impact leaf quality and the final cigar flavor. After curing, the properly dried tobacco leaves move on to fermentation, an essential stage for refining flavor and stabilizing leaf structure. The leaves are stacked into large piles called pilones, where heat naturally builds up through biological decomposition. During this phase, unwanted compounds such as excess nicotine and ammonia are removed, while natural aromas are enhanced. Workers regularly turn the piles to control temperature and humidity, and lightly moisten the leaves to maintain optimal conditions. Once fermentation is complete, the tobacco leaves are carefully sorted based on size, color, softness, and flexibility. Each cigar requires 3 types of leaves: the wrapper, outer layer; the binder, middle layer; and the filler, inner core. The wrapper is the outermost leaf, directly impacting the cigar's appearance and flavor. The binder holds the filler together, providing structure, while the filler, the heart of the cigar, is made up of several smaller leaves blended according to a specific recipe. This filler blend is what gives each cigar its unique flavor profile and signature character. For premium cigars like those from Cuba or the Dominican Republic, hand rolling remains the gold standard. Skilled artisans carefully select the appropriate filler leaves, arrange them according to a specific blend, then roll them tightly with a binder and finish with a smooth wrapper. Each cigar is shaped, the head is twisted, then it's placed into a mold for pressing and undergoes thorough inspection before storage and packaging. While each artisan can roll only a few dozen to a few hundred cigars per day, their precision and craftsmanship result in a level of quality that's unmistakably superior. Although the cigars are already complete in appearance, they still require time to rest. This post-roll aging stage lasts from 2 weeks to 3 months, allowing the tobacco leaves to blend and the flavors to stabilize. During this period, the compounds in the filler, binder, and wrapper gradually harmonize, creating a balanced aroma, taste, and burn. As a result, the cigars reach their ideal state before being packaged and shipped. Meanwhile, in large-scale factories, automated cigar rolling machines are used to boost productivity and standardize the product. First, tobacco leaves are fed into the machine and cut to pre-programmed specifications. Once the filler, binder, and wrapper layers are precisely arranged, a system of rollers tightly wraps them into the shape of a finished cigar. The head of the cigar is then neatly twisted by the machine to ensure uniform size and appearance. Next, the cigars pass through a preliminary inspection line before moving on to the next stage. Specialized equipment is used to assess the roundness, firmness, and tightness of the cigar's head, as well as the condition of the wrapper surface. Any cigar showing defects, such as loose rolling, torn wrappers, or incorrect dimensions, will be rejected or redirected to a separate category for further handling. After that, each cigar is carefully wrapped in a thin layer of nylon to protect its outer structure, maintain optimal humidity, and ensure complete hygiene. This wrapping also helps shield the cigar from environmental factors during transportation and storage, preparing it for the final packaging stage. And now, let's explore the cigarette manufacturing factories, where each cigarette is produced through a closed-loop process that is both rapid and highly precise. Unlike the artisanal craftsmanship of hand-rolled cigars, cigarette production is highly industrialized, driven by extensive automation and advanced technology. Unlike cigars, which require each leaf to be hung individually, tobacco leaves used for cigarettes are typically stacked in large cages or mesh containers, then placed into sealed curing chambers with automated temperature and humidity controls. These high-capacity systems operate continuously and can cure several tons of leaves each day. The drying process removes moisture and stabilizes the leaf structure, preparing them for further processing. Once the leaves reach the desired moisture level, they are compressed into tightly packed bales for easy storage and transport to the main processing plant. At the factory, the tightly packed bales of tobacco leaves are unpacked and fed into a modern cutting system. Here, the leaves are shredded into fine, uniformly sized strands, making them easier to roll into paper and ensuring a consistent, even burn in every cigarette. These shredded tobacco strands are then moved into a blending process that follows a proprietary formula unique to each brand. In addition to the primary tobacco material, the blend may include several additives such as flavor enhancers, humectants, and aromatic agents, designed to smooth the draw, adjust the scent, and enhance the overall smoking experience. The entire process is strictly monitored and controlled to ensure uniformity and maintain the final product's quality standards. Once the tobacco filler is ready, the automated production line feeds it into specialized rolling paper tubes, ensuring an even burn and controlled smoke output. The processes of rolling, cutting, attaching the filter, and shaping the cigarette are all fully automated, producing thousands of cigarettes per minute with high precision. Once the finished cigarettes meet quality standards, they are transferred to a fully automated packaging line, a highly precise and tightly controlled process. Every 20 cigarettes are neatly aligned and inserted into a specially designed cardboard box. These boxes are built to withstand transportation while also clearly displaying the brand's colors and imagery. Next, each pack is wrapped in a layer of foil or thin aluminum film to preserve the aroma, block moisture, and shield the contents from environmental factors. This is followed by an outer shrink-wrap plastic layer, which enhances durability and gives the final product a sleek, polished look by the time it reaches the consumer. Thanks to advanced automation, modern factories can produce hundreds of thousands to millions of cigarette packs per day with near-perfect consistency. And that is the meticulous journey, from delicate leaves swaying under the sun and wind to the iconic product of a multi-billion-dollar industry. Are you curious about how farmers cultivate the vast tobacco fields behind the billions of cigarette packs produced each year? That journey begins with tiny seeds carefully germinated in soil trays or greenhouses, where light, temperature, and humidity are strictly controlled. After about 4 to 6 weeks, once the seedlings reach a height of 15 to 20 centimeters, they are transplanted into the fields. Today, instead of planting each seedling by hand, many modern farms use specialized tobacco transplanters. These machines can automatically drill holes, place the seedlings, cover them with soil, and gently press the surface, all in a single pass. Thanks to this technology, thousands of tobacco plants can be planted in neat, uniform rows within just a few hours, saving labor while ensuring optimal spacing between plants. Tobacco thrives in loose, well-drained, nutrient-rich soil. Throughout its growth cycle, chemical fertilizers, pesticides, and herbicides are frequently applied to prevent pests and diseases and to ensure the leaves meet commercial quality standards. However, the heavy reliance on these chemicals silently contributes to soil and water pollution, posing a serious threat to the surrounding ecosystem, an often overlooked dark side of cultivating one of the world's most profitable industrial crops. Now, each time you hold a cigarette in your hand, the smoke you exhale carries more than a habit. It embodies the essence of the earth, the sky, and the hands that shaped it. No matter where it's produced, the journey of whey protein always begins on lush green pastures at dairy farms, where healthy cows, raised with the utmost care, produce high-quality fresh milk that lays the foundation for the extraordinary transformation that follows. When male calves are born, they are often not raised on their mother's milk like female calves. Instead, they are taken on a different path, sometimes becoming food, or contributing to cheese production, where enzymes from their stomachs are used as rennet. It is a quiet yet familiar part of the agricultural cycle, where even the smallest lives play a role in the larger picture of nature and human activity. On average, each cow can produce about 30 liters of fresh milk per day. Of this, only about 3% is protein, and nearly 1/5 of that precious protein is whey. Before each milking session, the cows are led from the resting area to the milking area. Accustomed to the regular routine, they walk in a row, slowly and calmly. The walkway leading the cows is designed to be spacious, with slip-resistant floors to reduce stress and prevent slipping. In the milking area, the cows are arranged in parallel rows or angled to one side. The staff cleans the udders with a clean towel and disinfectant solution, then attaches the milking machine to each teat. The machine works by creating suction pressure that mimics the natural sucking motion of the calf, making the cow feel comfortable and relaxed. After 5 to 8 minutes, the milking unit automatically releases, and the udder is cleaned again with an antimicrobial solution to prevent infections. Especially in large-scale farms, the automatic rotary system is the optimal solution. Cows step onto a giant rotating platform that moves slowly. Once the cows stabilize their position, workers attach the milking machines while the platform continues to rotate. The cows are milked while going around, in a completely relaxed state, even continuing to chew their food. After completing one full rotation, the milking unit automatically releases, and the cow leaves the system to make room for the next one. Thanks to this mechanism, a rotary system can continuously milk hundreds of cows per hour while ensuring comfort and efficiency. The milk then flows into storage tanks and is transported in insulated tankers to the factory, ready for the whey protein production process. When fresh milk arrives at the factory, it must pass a series of strict quality checks, like a quality passport, before being allowed into the production line. The journey begins in massive sterilization tanks, where the milk is rapidly heated to 72 degrees Celsius for a few seconds to eliminate bacteria, then quickly cooled to preserve its freshness and nutrients. From there, the milk moves into the cheese-making process, where whey, once considered a waste product, begins its transformation into the white gold of the fitness world. After pasteurization, the milk undergoes a magical transformation when rennet, a traditional enzyme specially extracted from the stomach of young calves, is added. Like a natural miracle, this enzyme causes the proteins in the milk to bind together, turning the ivory white liquid into a smooth, thick mass. In less than an hour, separation occurs. The thickened part is called curd. Once the milk has coagulated into a thick, jelly-like mass, sharp blades begin to move, slicing the curd into evenly sized pieces, about the size of small beans. This cutting process not only breaks the curd into smaller portions but also plays a crucial role in optimizing the separation of liquid, allowing the whey to drain more efficiently from the curd. Immediately after, advanced robotic arms begin to stir the mixture with smooth and precise motions. This continuous movement gradually causes the whey, a pale yellow liquid rich in protein, lactose, vitamins, and minerals, to separate from the solid curds. The stream of whey is passed through multiple layers of fine filtration to remove milk residues, bacteria, and impurities, leaving behind only a clear, clean liquid. Next, the whey is quickly pasteurized at a temperature of 72 to 75 degrees for about 30 seconds, ensuring microbiological safety and preparing it for the next processing stages. Next, the liquid whey is sent into an evaporation system to remove excess water. This process is carried out at low temperatures to preserve the delicate structure of the proteins. Once the desired concentration is reached, the whey moves into a specialized drying chamber, where alternating streams of hot and cold air rapidly remove the remaining moisture. The result is an ultrafine whey protein powder with extremely low humidity, ideal for long-term storage, easy blending, and optimal nutritional quality. Once the whey powder is completed, it is screened to remove any large particles, then thoroughly blended to ensure uniformity. Before packaging, the product must pass a series of strict quality tests, including protein content, moisture level, solubility, and microbiological safety. Only the batches that meet all standards are allowed to proceed to the next stage. The qualified whey powder is transferred to storage, then moved to the weighing and batching area. All the powder is sieved through a 2 mm mesh to achieve uniform fineness, ensuring an efficient and consistent blending process. Next, the whey powder is blended with flavorings such as vanilla, chocolate, strawberry, or caramel, depending on each product's formula. This process takes place in giant rotating drums that can produce over 10,000 packets of whey per day, operating continuously 24/7. After the blending process is complete, the whey powder is transferred into large hoppers, which act as holding stations, readying the product for packaging. From there, an automated filling system precisely and efficiently dispenses the powder into individual containers. For products packaged in jars, each empty jar is placed onto a conveyor belt and moves steadily toward a precision weighing station. Here, the system carefully measures and fills the exact amount of powder required for each unit, with accuracy down to the gram. Immediately afterward, a small plastic measuring scoop is automatically dropped into the jar, ready for consumer use. The jars then move directly to the labeling area, where product labels are applied to each jar neatly and evenly, ensuring that important information such as the brand, nutritional content, and usage instructions are clearly displayed. Next, a protective ring is applied to the jar's mouth, and it is heat-sealed tightly, creating a secure barrier that prevents moisture and bacteria from entering. This process helps protect the powder inside, keeping it dry, clean, and ensuring optimal quality throughout its shelf life. For pouch packaging, the process begins with a roll of pre-printed film, which is fed into an automatic pouching machine. The machine then shapes the pouch, seals the bottom securely, and automatically fills it with whey protein powder with high precision. Once the pouch is filled, the top is heat-sealed, creating a perfect protective barrier to prevent moisture and keep the powder dry. This process occurs continuously, quickly, and with utmost accuracy, ensuring that each pouch meets the highest quality standards. Finally, the finished products are carefully packed into cartons, ready to leave the factory and begin their journey to consumers around the world. Each carton carries a commitment to quality and care, ensuring that pure nutrition reaches every corner of the globe.